So we're building these incredible AI agents, right? They can write code, they can do all this amazing work, but they have this one giant fundamental flaw. They can't remember a thing. Today, we're going to dive into how we fix that, how we give AI the one thing it's been missing, a memory. I want you to just think about this for a second. What if the smartest AI on the planet had the worst memory you can possibly imagine? I mean, so bad that it forgets absolutely everything the second its task is over. And this isn't some sci-fi scenario. This is the reality for AI agents today. See, they're powered by large language models, which means they're what we call stateless. They basically live in a constant now, with zero memory of what happened even a minute ago. All right, so what's really going on here? What's causing this agent amnesia? To get to the bottom of why these AIs are so forgetful, we've got to pop the hood and see how their memory works, or, doesn't work. Okay, so its whole memory, everything it knows, lives inside this thing called the context window. And honestly, the best way to picture this is to think of it like the RAM in your computer. It's super fast, super useful for whatever you're doing right now, but it's totally temporary. It's volatile. The second you close that program, poof, it's all gone, vanished. And that is the heart of the problem. The context window is just temporary RAM. What these agents desperately need is a hard drive, a persistent place to store things, where their work can actually survive between sessions. Without that, how can an agent ever learn from what it did before? How can it build on its past work? It can't. Now, I know what some of you are probably thinking right now. Hey, what about RAG? And yeah, Retrieval Augmented Generation is a really clever trick. It basically connects the AI to a big database of info. It lets the agent look up old documents or data and pull what it needs into its little temporary memory, its context window. And it's awesome for solving the input problem, getting information in. But, and this is a big but, it has a huge flaw. It's read-only. That's the problem. The agent can look, but it can't touch. It can't save anything back to that database. So if it writes an amazing piece of code or comes up with a whole new business plan, that work just evaporates when the session ends. It doesn't solve the output problem at all. So that brings us to a totally new kind of solution, and it's called agentic storage. It is, pretty much literally, the hard drive that these AIs have been waiting for. But look, agentic storage is way more than just a digital filing cabinet. It's a storage layer built from the ground up for these autonomous agents. It's what lets them save their work, their learnings, their breakthroughs, so they can actually carry that knowledge from one job to the next. Okay, that sounds great, but how do we actually plug this in? I mean, are we gonna have to write some crazy custom code for every single type of storage out there? Like one for S3, another for a local file system? Ugh, that sounds like an absolute nightmare to maintain. Well, thankfully, the answer is no. The industry is starting to come together around a standard called the Model Context Protocol, or MCP for short. And you can think of MCP as the universal translator between the AI and, well, pretty much any storage system you can throw it at it. So here's how it works. The protocol boils everything down to just two simple ideas. First, you have resources. This is basically how the agent reads stuff, files, database records, that kind of thing. Pretty similar to RAG, right? But here's the real game changer. Tools. These are actual functions the agent can run, like write file. The agent just has to say, hey, run this tool, and MCT takes care of all the messy, complicated stuff on the back end to make it happen. But, okay, this brings us to a huge new problem, a serious one, because by giving an AI a hard drive, we've also given it the power to write, to change, to maybe even delete data. We've basically just handed over the keys to the entire kingdom. And you can bet this is the exact question that's keeping security folks up at night. I mean, you can just hear them. Wait a second. You're telling me we're about to give a fallible, unpredictable AI write access to our company's most important data? And look, that's a totally fair question. We all know these agents can just make stuff up. They hallucinate. We know they can get our instructions wrong. An agent might do something that sounds perfectly reasonable, like delete old log files to save space. But in the wrong context, at the wrong time, that could be an absolute disaster. And that is precisely why agentic storage can't just be just any old storage system. It has to be built from the ground up specifically for AI. It has to come with a built-in, super robust safety net. This safety net is really built on three core layers.
Now, for a person, these might seem like overkill, but for an AI agent flying solo, they're non-negotiable. Let's break them down one by one.
Okay, safety layer number 1, immutable versioning. This is huge. It means every time the agent writes something, it doesn't just overwrite the old file. It creates a brand new version. Think of it like a permanent save history. The agent can never truly destroy data. This gives us a perfect audit trail and, best of all, a big red undo button to roll back anything it does instantly. Number 2, sandboxing. This one is absolutely fundamental. We put the agent inside a little digital box, a constrained environment. So if its job is to organize log files, that's literally all it can see and touch, that one directory. It has zero ability to wander off and start messing with critical system files or anything else. It keeps the agent focused and prevents it from causing chaos if it gets confused. And finally, the third and maybe the coolest layer, intent validation. This is like making the AI show its work. Before it's allowed to do something really big, like delete 1,000 files, the system stops and asks, hey, why are you doing this? The AI has to explain its reasoning, something like, I'm deleting these because they're over 90 days old, and that matches the company policy. The system then checks if that's actually true before it lets the command go through. It's a critical final check. So, there you have it. By combining this new kind of hard drive with a powerful safety net, we can finally solve the AI's memory problem. We're on the cusp of moving from these forgetful, one-shot agents to truly stateful ones. Agents that can learn, that can build, and that can get better over time. Which, of course, leaves us with one massive, exciting question. Now that AI can finally remember, what will it build?